In this video, we're going to work on adding and subtracting rational expressions. Right? So the big thing to remember about adding and subtracting fractions, right, is that if you have something like 1/5 plus 2/5, that we need the denominator, the bottom number, to be the same, and we add the tops to say it's 3/5. Okay. You don't add the bottoms or anything like that, because the question you're trying to answer here really is like, let's say, you know, this is representing I ate 1/5 of a pie. You know, is kind of maybe the scenario here, right? Pretend that's 5 equal pieces. So I ate 1/5 of the pie. Then someone else came and ate 2/5 of the pie. So how much has been eaten? 3/5 of the pie, right? So here's an example where, yeah, we've got the same denominator in both fractions. So what that means is that all I have to do is take the numerators and add them together. So 8x plus x would be 9x. But then anytime we add fractions together, we need to make sure that the final answer is reduced. Now x and y, can't do anything with that, but we can certainly divide the denominator by 3 to make 1, divide the numerator by 3 to make 3. So my final answer here would be 3x over y. Here's another one where the denominators are the same, but there is definitely a little complication here we got to be careful of. So let's zoom in a bit more here. So as I go to subtract these, there's multiple terms in the numerator that I want to subtract off, right? There's an x minus 3. So this is very important. When we go to put these together, I've got my 2x plus 3, and I'm subtracting off all of x minus 3. So it's really important to put it in parentheses. If you don't put parentheses around it, then it will look like all you're doing is subtracting the x. Okay, so just if it looked like this, then you're just subtracting the x and not the -3 also. You've got to have parentheses around it so you're subtracting off the whole thing. And then of course, just like we talked about distributing through before, that negative is like a -1 distributing through to both of these terms. So I end up with 2x plus 3 minus x plus 3 over x plus 1. So this is x plus 6 over x plus 1 as my final answer. All right, so we mentioned that we do need to have the same denominator in order to add or subtract fractions. Okay, but what if we don't? Right? What if we don't? Well, let's take these fractions here. Let's say I wanted to add these fractions together, or I wanted to subtract these fractions. Then I would need to find a common denominator for these. Now, 12, 16, and 20 are not the friendliest numbers to try to find the least common denominator of. So it might not jump into your head right away what the appropriate answer is. So if that's the case, remember we can always prime factor our numbers. We'll do that here. So remember, least common denominator, we're looking for a number that all three numbers can divide into evenly. So here's the way to approach this. If 12 is going to fit in to our number, the fact that 12 has a factor of 3 means our number has to have a factor of 3. And the fact that 12 has 2 factors of 2 means that our number has to have 2 factors of 2. I'm going to skip over to 20 here. 20, okay, has a factor of 5, so our number better have a factor of 5. And it has 2 factors of 2. But guess what? Our number already has 2 factors of 2, so no need to put any more in there at this point. But 16, now we look at that. 16 has 4 factors of 2. Okay, so that means our number needs 4 factors of 2. So when we multiply all this together here, let's see, what do we get? We get 240. Okay, so that would be the smallest number that 12, 16, and 20 all fit into evenly. Now, just to, I know this isn't exactly what the question asked, but I'm going to extend this a bit. Once you determine that 240 is the least common denominator, the idea is you want to actually turn each one of those denominators into 240, but you want the fraction to be equivalent. So you ask yourself, what do I do to 12 in order to make 240? Well, the answer is you multiply it by 20. You can do that so long as you also do that to the top of the fraction as well. So 5 times 20 is going to give me 100 on top. 16, so what do I do to 16 in order to turn it into 240? I'm going to multiply that by 15 to make it 240. Okay, and how do I know that, by the way? There's tricks for figuring that out just from the prime factorization, right? So the fact that 16 is 2 times 2 times 2 times 2, 15 is the part of the least common denominator that's left over, so that's how I knew to multiply by 15. Or, of course, you can just take 240 divided by 16. You get 15. Right? That's another way to figure it out. Okay, so then 20, what do we do there? Well, 12 is what I multiply by to make 240. All right, so what do I get there? So 156, I think. All right, so at this point then I can add them all together. So 256, 261, 271 over 240. Now, of course, I'd want to make sure that I reduce that, but the point being, the main thing that we want to take away from this is we find what the least common denominator ought to be, then we multiply on top and bottom in order to make that least common denominator happen for each fraction. All right, so let's put this into practice when it comes to expressions that might have variables involved. All right, so first of all, what did we do to find that LCD on the previous page, the least common denominator? We completely factor each denominator, and then the least common denominator is the product of all the unique factors found in step 1 to the power of the greatest number of times it appears. So what that meant was 5 appeared, 3 appeared, and 2 appeared. Okay, but then you raise it to the power of the most number of times it shows up. So 5 only showed up once, that was the most it showed up in any number. 3 showed up once. And then the most number of times 2 showed up was 4. And so, of course, that's the same as 2 to the power of 4. So that's what that rule's talking about. And then when we actually want to add and subtract rational expressions like this one, we're finding the LCD, we're rewriting each rational expression so that the denominator is the least common denominator, and then we can add and subtract. And of course simplify if need be. All right, so here, as we look at this, a lot of times it helps to just think about this in chunks. So like 8 and 10. Now, 8 and 10, if you very well may be able to just look at that and figure out that the smallest thing both go into is 40. Okay. Now, if you did not remember that, what you would do is you'd say, oh, okay, 8, 2 times 4, 2 times 2, 10, 2 times 5. And so your LCD has to have 2 to the 3rd power, because that's the most number of times 2 shows up in any number. times a 5, and that equals 40. So we know we're aiming for 40, but then what about the variables? Well, we look at x and x squared. We want the most number of times x shows up, so it shows up the most in this fraction, and 2 factors show up, so x squared is what we want. Y shows up here once, none here, so times y. So there's our LCD. So now what we're going to do is we're going to make each of those, and actually it's kind of small, so let me rewrite those. But we want to make each of these denominators become 40x squared y. Excuse me. We do want it to become 40x squared y, but let me write this out correctly. There we go. And in this step, I want them to become 40x squared y. All right, so we have to ask ourselves, what do we have to do to this fraction in order to make 40x squared y? Well, to turn 8 into 40, I know I need to multiply by 5, so I better do that on top and bottom. And then it looks like I need x to the power of 2, so that means I'm going to need another x that I'm multiplying by. And then over here, what do I do to 10? Well, I better multiply it by 4 to make 40. And then I'm going to need a factor of y, so I better multiply by that also. So what we get is in that first fraction, we get 25x. In the second fraction, we get 44y. And so then I can put those together. 25x plus 44y divided by 40x squared y. And I can't see any obvious reducing I can do. Remember, I can't cancel these y's out. Why? Because there's a plus sign there, right? We cannot cancel terms. Only if we can factor something out can we maybe cancel. All right, now here's one where you're looking at these, and if you notice that something can be factored, you need to do that in order to be able to figure out what the LCD is. So I want to rewrite, first of all, this fraction so that the denominator is in its factored form. And then, at this point, I can much easier be able to see what the LCD is. Now understand what's happening here is that I've got a factor of x plus 3 and a factor of x minus 3 over here. This one already has a factor of x plus 3, so when I'm thinking about my least common denominator, I want my least common denominator to have an x plus 3. Both of them already have it, so I only need one of those in my LCD, but I do also need an x minus 3. So this is a situation where you actually don't have to touch this fraction at all. The only thing I have to do is multiply by x minus 3 in the second fraction so that they can both have the same denominator. So understand that this situation's just like if I was asking you to take 1/5 plus 13 25ths. You would look at that and say, well, okay, this has, and maybe actually let me slightly change my example. 13 20ths. Okay, so you can say, well, this has a factor of 5, but of course this has 5 times 4 is 20. So in the end, the LCD is still just 20, right? That would be your least common denominator of these, because all you'd have to do is multiply by 4 on top and bottom to make the least common denominator for this one. So that's kind of like what we have going here with this fraction. So now, of course, I'm careful to keep these parentheses for the moment. And then as I distribute here, I'd make sure I distribute that -5 to -3. So we end up with 5x plus 15 over x plus 3 times x minus 3. Now before we pat ourselves on the back and say, great, we're done, we do want to check to see if there's any reducing that can happen. And in order to see if there's any reducing that can happen, things should be completely factored out. And I can see that 5x plus 15, I can pull a 5 out of that. Which allows me to see that actually there's a common factor of x plus 3 on top and bottom. So my final answer here is actually 5 over x minus 3 when completely simplified. Okay, so on the one hand, these examples on this page each have a little wrinkle that's makes them a little bit tricky. At the same time, I think that you know enough now that it would be good to try these on your own first. So I encourage you to pause the video, give them a try, and then you can unpause and kind of watch my solutions of them. All right, so if I have these two fractions here, you look at these two denominators and notice how similar they are. And in fact, this is an x, this is a negative x. This is a -6, that's a +6. So they're just opposites of one another. So we did this in one of our, I think, multiplication or division examples, where we recognize, well, you know what, we can actually make these the same by factoring out a negative. Okay? Factoring out a negative, oops, sorry, I didn't mean to write 6 twice. There we go, x. Factoring out a negative. So one of the things, just over as an aside here, I'll put this in yellow over here, if I take -3/5, that's the same as if I took -3 over 5, and it's the same as if I took 3 over -5. So if I have this negative sitting down here, it can come up front. And if I have minus a negative, I know that that is, let me just write it out, minus a -9 over, and hey, while I'm at it, let's rewrite the order. Let's put the x first and the -6 second. But I have minus a negative, I know that turns into plus a positive. Okay, so 19 over x minus 6 is what I get there. So be careful of that, right? Don't start multiplying a bunch of stuff out when all you have to do is factor a negative out, and then you have your least common denominator just right there. All right, here's another just kind of wrinkle. What if I have like a whole number or something like that, or even if it had variables in it, but it's not a fraction, minus a fraction. So just remember the old trick that 2 is always the same as 2 over 1. And so if that's the case, then your least common denominator is just going to be whatever this denominator is. So I can just multiply by x plus 4 on the top and the bottom. And then this is again one of those examples where it's important to use parentheses. I'm subtracting multiple terms, so minus parentheses x minus 3. So 2x plus 8 minus x plus 3, right? -1 times -3 is plus 3. And then finally, x plus 11, it looks like, over x plus 4. All right, then lastly, what makes example 15 a little bit different? Well, here, when you go to factor, it's really nothing really different than what we've talked about. But when I go to factor this one, I get x plus 2 times itself, right? And I get, on this one, x plus 2 times x minus 2. So when it comes time to identify my LCD, remember the principle is we factor, and then we take each factor raised to the power of the largest number of times it appears in any one fraction. So the fact that I have two factors of x plus 2 in this fraction, that means I need 2 factors of x plus 2 in my LCD. I have 1 factor of x minus 2 in this fraction, so I need 1 factor of x minus 2 in my LCD. And so then I can go through and I can multiply by what I'm missing, right? So this one's missing an x minus 2. And this one is missing 1 factor of x plus 2. So this becomes 6x times x minus 2 over x plus 2 squared times x minus 2, and x times x plus 2 over x plus 2 squared times x minus 2. But of course I can get these together, and at the same time, actually, let me set a good example. It would not be bad at all to go ahead and multiply out the the tops here, but just not to do too many steps at once. Especially because it really does, you have to be more careful when that's a minus. Now in this step, I'll go ahead and distribute through to both of those. So 6x squared minus 12x plus x squared plus 2x plus 2 squared times x minus 2. So I end up with 7x squared minus 10x over x plus 2 squared times x minus 2. Now technically I can factor an x out of the top. However, I can see that by doing so I'm not going to get anything that'll cancel with something on the bottom, so I'm not going to bother. And we'll say that that is my final simplified answer.